Okay, welcome to part 3B, which is the continuation of the analysis section, analyzing data. So, in here, what I want to be able to do is in the first part of this analysis, I went through selecting the analyses and actually running those analyses. Now I'm just kind of reporting those results. So, this is more about the text that has to do with supporting the analysis section rather than the our studio portion of it. So we're going to look at the output and we're going to look at what we've written for that. So in the exemplar here, if we move past the considered data in the analysis section, we notice we put in the overall box and whiskers plot of the calories, so we get an understanding of the distribution, slightly skewed here. And so I ran the fave stats on the overall as well. And what I sort of noticed here and what I reported on was I want to talk about the center and I want to talk about the distribution. So first I say here, the figure one is suggests that the distribution is somewhat skewed right? We've got some extreme values that are out to the right here. I report the mean and the mean being 170 and the median being 150. And that makes sense because it's skewing it higher than it should be. So given this degree of skewness, about 20 calories, we're going to go with the median as the measure of most typical snacks. Um, also talk about the variation again in the context of the skewness. We have these extreme snacks that are about 100 or 830 calories, which is a lot. And again, most of those are in the upper extremes. Um, so that we can kind of see what these measures of spread do for us, and we see that the interquartile range for the 50% in the center is about 100 calories. So we see that the calorie variable itself is okay. It's got variation and it's got a understandable typical value of about 150 calories. When we look at the times of day, I wanted to look at this because I want to make sure that like all of the times of day are represented for snacks. What we don't want to see is a non-uniform distribution here. We don't want to see like everyone's eating snacks in the afternoon and there's nobody eating, or there's one category that's really underrepresented. This is actually, it's kind of surprising to me, but it's a good thing that we have kind of an equal number of cases across the different times you could eat a snack. So that's kind of optimal because we don't get like sample size issues that might skew our results. So that was a pleasant surprise. I was not expecting that. And you can kind of see I ran like a tally function here and gave the percentages of all of the um, times that snacks were consumed. And I sort of wrote that up here that the most popular times are morning and afternoon with about almost 30%. Just the third highest time was the evening at almost 24%. And the one that's the least represented, even though I still think there's a good number here, um, like 16 to 17% are in the nighttime. So I feel like we're at least getting all the categories represented. So grouping them by times of day makes sense. Just like if you grouped by the salty sweet, for example, you wouldn't want like no salty and all sweet. It's not really a good comparison. So that's a good sign for us. So I feel like we can proceed with our those two pieces of information together. We can proceed with the faceting part, kind of blending these two together. When we look at these box plots, again, they're not the biggest graph here, and we're not going to spend a ton of time dissecting it, but we can see some really interesting patterns already. First of all, we see that the morning's got a lot of variation to it, real extreme snacks. So does evening. Um, but the others don't have the same extreme values in them. We can kind of get a sense also if we look at 150 as the marker for snacks, we can see that the morning snacks look to be much higher than that, probably closer to 200. And then the afternoon ones are much lower, looks like. But again, we can run the fave stats to see those faceted out by their slots. So again, distributions, when we talk about some of these probably the median is going to make the most sense again because of some of these pretty skewed results. So if I look in table one, I kind of highlighted this, so feel free to use something like this when you're fasting out. I purported the mean and median just to see if there was differences, and make the case for using the mean or median based on skewness or no skewness. And then the 5 number summaries for just for understanding the global picture, and particularly the range in the IQR for understanding distribution. This is really cool. I think the results pop out pretty well. So, for example, overall, we're eating snacks with about 150 calories. Morning snacks are 10 calories higher, and afternoon snacks are 20 calories lower. So, those two extremes, you can kind of see some interesting stuff going on. Clearly, high caloric snacks are happening in the morning, and there's also more variability here. Um, just this is relative to the other time periods, right? So the IQR, which is 50, the middle 50% of students, that's ranging by like 100 calories. Whereas in the afternoon, it's 20, more than 20 calories, or actually about 20 calories um, difference. So that's pretty good size difference, I think. So that kind of covers like all the things that we would want to say in here. I want to talk about the the central tendency for the groups, and then we would like to talk about the variation in the groups, and that's it. We don't want to draw conclusions from that. We just want to report what those are. And if you read this, you see that I talk about both of those in each of these pieces. So hopefully that helps with the completing the analysis section of the practice.